Right, good morning, boys and girls. Welcome to probably the most riveting video on YouTube. Mr. Fitzpatrick explains some problems you might be having with your Planet Maths work. Yeah, so today we're going to be looking at area and perimeter. Um, I'm going to leave timestamps in the description below so you can click on the parts that most interest you. Stay around for a message at the end because I think that's quite important. Okay. As always, I'm going to try and put some way for you to respond to the work in the video, so some way to let me know that you're doing okay. So what I'm going to do is I should have little cards in the corner, and it will give you an answer to 4 possible questions. So kind of to let me know how you understand each section. So the first section, if you totally understand something, you say, I totally understand that. I totally understand that. I'm pretty sure I will get it right. I'm not really confident. And Mr. Fitzpatrick, did I ever tell you I was deadly at maths? Which is obviously my go-to thing when I am saying that I don't understand something. So you should be able to click those in the corner related to each topic that we cover. Okay, let's take a look at the first couple of questions we had. Well, the first one was comparing rectangles. So what is the perimeter and what of each rectangle? So I always think of perimeter as if I'm decorating my house, and areas I'm decorating my house. So I think if I was putting down new carpet in my bedroom, I'd have to find out the area of the room. How much floor space is there in that room? How much flat space is there in that room? That's area. And we measure that in centimeters squared or meters squared, or if I had a really big room, maybe kilometers squared, but I don't think that exists. Um, and then if I'm trying to work out perimeter, perimeter is the area around the shape, so around the shape. So that would be like the skirting board. So how much skirting board will I need? Well, I better figure out the perimeter of this shape. So let's take a look at the first one. Okay, here, the green one. So let's work out the perimeter first. So the perimeter is 1 on this side, and if it's 1 on this side, it's 1 on this side. So 1 plus 1 is 2. And on the top, it's 6. So 6, and if it's on the top, it's 6, the bottom is 6. So 6 and 6 is 12, 1 and 1 is 2, 12 and 2 is 14. So if you said the perimeter of this room is 14 centimeters, you're absolutely right. Then if I was working the area, well, the area, we multiply one side by the other. So 6 multiplied by 1. 6 times 1 is 6, and then centimeters times centimeters are centimeters squared, as we'd call it. So 6 centimeters squared is the area of this. So for this one, the perimeter is going to be 8 and 8, or sorry, 4 and 4 is 8, and 3 and 3 is 6. 8 and 6 is 14 centimeters squared, or 14 centimeters. It's the perimeter, so it's 14 centimeters. Well done if you got that right. And the area, well, that's a multiplication question. 4 times 3 is 12. So 12 centimeters squared. The last one, the perimeter, 5 and 5 is 10. 2 and 2 is 4. 14 centimeters squared, or 14 centimeters. And then 5 times 2 is 10. 15 centimeters squared. So hopefully you got all those right. We've been doing that for a while, so I hope you got all those right. So the next question I asked you to do was to draw these rectangles, so using a ruler. I'm sure you had very little problem with that, and again, it's the same kind of question, so I think I can move on for them. So well done, anyone who's got that, and if you have any problems on that front, please let me know. Okay, so then we move on to our next page. Okay, and I scroll up if I can. Okay, so these ones are a bit more tricky. We need to engage our brain to do it. So what we have to do is we have to break these shapes up into two. So for example, the first one I would draw an imaginary line there. Now, if you drew an imaginary line here, that's totally okay too. So I need to figure out what is the length of this up here. So I have 4 and 2 is 6. That means I know the top is 6 and the side is 2. And am I trying to calculate the area? Sorry, I can't really see now with all the doodads here. So estimate the area. So yeah. So if the top is 6 and the side is 2, that means the area of the top box, 6 times 2 is 12 centimeters squared. Click, click, click. Then, once I figured out the top, I can figure out the bottom. So it's 6 centimeters by 2 centimeters. Well, 6 times 2 again is 12. So if you put 12 and 12 together, you get 24. So if you are 24 centimeters squared for the first one, really, really well done. Again, I draw my imaginary line. Oh, great. This one's ready for me. 3 times 4 is 12. So I can figure that one out straight away. Now I need to find out the length along the bottom. Well, it's going to be this 3 plus this 3 is 6. That's a perfect 6 centimeters. And if I'm working out the area, I multiply the length by the breadth, or the length by the width. So 6 times 3 is 18. So that means the measurement of the whole lot, 10 plus 10 is 20, plus 10 is 30. So if you wrote 30 centimeters squared for that one, really, really well done. Okay, the last one is a bit different. So there's a couple of ways we could do this. There's the lazy way, and there's the more steps way, the easy way. Depends whether you like being lazy or easy. So one way to do it would be to get the area of these, and then to get the area of the square. So let's do that together now. So each of the lengths are 4. So 1 times 4 is 4. So that means each of the, if this is a fork, looks like the top of a fork to me, the prongs of a fork. So each one is 4 centimeters squared. So again, if that's 4, this is 4. And if that's 4, this is 4. Okay, so then I have 4 centimeters along the side here. I need to figure out the bottom. Well, the bottom is going to be 1, 2, 3, 4, 5 centimeters. I just counted up the length, or the width, I suppose, the width, sorry, of each of these places, and I put them together. Because a line all the way across the top here would be the same as a line at the bottom, so it's 5. 4 times 5 is 20. So I have 3 times 4 is 12. 12 and 20 is 32. So if you got 32 for that, really, really well done. And as we're doing these, there should be a little thing appearing in the corner asking you if you understand them. Okay, so the fourth type of question we had today is when we're estimating irregular shapes. So I'm just going to do the red one first. So let's follow the rules. So estimate the area of the circle by counting the number of square centimeters. If half or more of the squares inside the circle, count it. So what we do is we count all the ones where there is a full square. So 1, 2, 3, 4. The next rule is we count all the ones that are over half. Well, that's over half, so 4, that's over half, 5. Is this over half? I don't think so. This one, definitely. 7. This one, yes. 8. This one, no. This one, it's a tough one. Yeah, I'd say so. 9. This one, no. No. This one, whew, it's getting close there. Maybe, I would say no, and this one I would say yes. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you wrote 11, I wouldn't disagree with you. So if you wrote 10 or 11 for that one, I would find it very, very hard to disagree with you. So essentially, you count up all the complete squares and then all the ones that have more than half in the box. Okay, so I said 10 for that one. So once again, if you understand that, guys, give me a little shout out in the little thing in the top right corner there saying, I completely understand, I think I understand, don't have a clue, or Mr. Fitzpatrick, did I ever tell you I was deadly at maths? Meaning I don't understand at all. Okay, so let's take a look at the last questions now. And these ones are probably the hardest. Not that they're hard, but they kind of might trick you. Okay, so here it says, how many square centimeters are in 1 meter? I know you're thinking, Mr. Fitzpatrick, that's easy. We've done that 1,000 times. And this is where I say, guys, did I ever tell you I was deadly at maths? Well, I know there's 100 centimeters in a meter. So that means there must be 100 square centimeters in 1 meter squared. Unfortunately, I'd be really, really wrong. That's okay. So if we take a look at this dog here, there's 1 meter squared here, and that means 100 centimeters times 100 centimeters. 100, we agree that there's 100 centimeters across and 100 centimeters up. That means the same 1 meter squared is actually 100 times 100, which is, we add two zeros onto 100, well, that would be 1,000, 10,000. Okay, so that means there's 10,000 centimeters squared in 1 meter squared. Okay, so that means whatever we expect the answer to be, we multiply by 10,000. Okay, so let's take a look at the first one here first. So 93,000 centimeters squared. What's that in meters? Well, I'm going to imagine that it's going to be 10,000. I'm dividing by 10,000. So move the zero place. 1, 2, 3, 4. Okay, so that means it would be, if you wrote 9.3 meters squared, you'd be absolutely right. Okay, so I can understand if we find that challenging, but as long as you divide by 10,000 when you're changing centimeters to meters, well, like we always do if we're doing it in reverse, if we divide it by 10,000, we're going to multiply by 10,000. 8.1 meters squared is going to be 81,000. So maybe you might find that difficult to imagine. Take a quick look and see if we can do a visualization on that might make it clearer. Okay, so this is the most visual way I think I can show it to you. So the small square on the left is 1 centimeter squared, and the big green square on the right is 1 meter squared. So you can see here that it's not just 100 times bigger, it's a lot more than 100 times bigger. It's actually 10,000 times bigger because it's 100 times 100. That's the best way I can help you. Okay guys, if you need any more help, feel free to ask me some questions on that one, and I'll do my best to help you. Okay, so mind yourselves and keep in touch. Thank you very much for the people who sent me homework on Aladdin. I saw some really fantastic work, and it really shows that people are motivated and are not going to sit idly by and want to get better. So really, really well done to people who sent me homework on Aladdin. I've been so impressed with everything I've seen so far. So well done, boys and girls in 6th class. I'll see you soon.